Alright, so let's work on these parabolas. Given f of x, find the vertex, axis of symmetry, maximum, minimum value, domain, range, intervals of increasing, decreasing, and sketch the graph. So we're just going to do the whole, every little detail that we could figure out about this parabola. So first thing that we got to talk about is finding the vertex. So that's where I'm going to start with this. When you start by finding the vertex, you have to notice what form we want it to be in. So let me write that down. What we want is we want f of x equals a x minus h squared plus k. This is the form of the parabola we want, and the reason is because that would mean, that would give us the vertex to be the point h comma k, and it would also give us the axis of symmetry to be x equals h. Okay, so that's what we're looking for. In order to make it look like x minus h squared, this is the completing the square that we're going to have to do. So let's go ahead and complete the square. So we've got f of x equals to negative 2x squared plus 12x minus 19. And when you complete the square, the first thing that you have to do is make sure that you factor out the coefficient that's in front of the x squared. So if I factor out a negative 2, I'd be left over with an x squared minus 6x. And I'm going to leave some space, and that minus 19, we're not actually going to factor anything out of that constant. We're just going to come back to that later. And then we're going to complete the square. So we'll ignore the constant for now, but let's go ahead and complete the square. So you take the middle number, which is negative 6, and you divide it by 2. Reduce it if you can, which in this case you can, and then you square it. Okay. Take the middle number, divide it by 2, and then you square it, and that's what you're going to add. So that's going to be a positive 9 that I'm going to throw in here. But keep in mind, it's not actually a positive 9. It was a 9 times negative 2. Technically, what I have there is a 9 times negative 2, which is a negative 18. So what we have to make sure we do is the opposite. So we have to go ahead and add 18 on the outside. Okay. Again, because it was a negative 18, we went ahead and added to make that a positive 18. All right, and then let's finish completing the square. So that'll give me negative 2. Now this polynomial factors into the x minus 3, which you can write as x minus 3 squared. And then you combine the like terms and the constant on the outside, and we get negative 19 plus 18 is the negative 1. So this is our new f of x. This is now what we're dealing with. We write it as f of x equals, this is now the polynomial. From here, we can certainly find the vertex. So let's go ahead and do that. We've got the vertex is going to equal 3 comma negative 1. Now where did we get those from? So the 3 comma negative 1 came from inside the parenthesis you changed the sign, and then outside the parenthesis we left it the same. Okay, that's what our x comma y ordered pair for the vertex is. A few more things that we had to find. We also have to find the axis of symmetry. So our axis of symmetry is always going to be an x equals. Okay, this is a line. It's a symmetrical. It's a line that this parabola is symmetric about, and it is always the x value of your vertex. So going back looking at your vertex, we ended up with x equals 3. Okay, so that's our axis of symmetry. A few other things that we have to find from here. We're going to talk about intervals of increasing, decreasing, max, min, etc. So let's talk about the max or minimum. Again, looking at our function, let me write it here one more time just so we can see it again. F of x was equal to negative 2 times x minus 3 squared minus 1. We've got our axis of symmetry, we've got our vertex. We're going to talk about a maximum or minimum value. If you look at the a value in front of the parenthesis, that negative 2, because it's negative, it tells us this is now an upside down parabola, which means it is actually going to be a maximum. Okay, so the maximum value is always the y value of the vertex. So a maximum value would be negative 1. Okay, and of course it's maximum because it's an upside down parabola. So we know eventually it's going to end up looking something like this. So that is a maximum value. All right, and then that also means we can continue on from here. We've got our maximum, our axis of symmetry, our vertex. Let's go ahead and graph it, and then we can find the domain and range later. Sometimes it's easier to find the domain and range after you've graphed it. Okay, so let's go ahead and graph it. What I did is I just created, excuse me, sorry about that. We're going to go ahead and create a few of these points, x, y ordered pairs. You can do a couple of different things. You can do an xy table if you'd like. Sometimes that xy table is helpful. First thing that you want to plot, though, is the vertex. So our vertex was 3, -1. So I'm going to plot that point at 3, -1. That's our vertex right there. And we can pick another couple of points. Maybe let's pick the x value of, let's say 2, and then maybe the x value of 4, one on each side of the vertex. So if you were to plug 2 in to your function, okay, so let's plug 2 into the function, and then see what you get. I'll let you guys do that. And you should have gotten the y value of -3. And then do the same thing, plug in 4 into your function. Go ahead and simplify that. And you would have actually also gotten -3, nice and boring. Okay, so let's go ahead and plot those 2 points. So 2, -3 be another point I plot, and then 4, -3 be another point I plot. So that's what we have. Those are just a few. I mean, you can certainly do more x, y values if you'd like. But we do know that's going to connect, and we know it's going to be an upside down parabola. So this does look pretty close to what we expected. So there is our sketch of the graph. From here, looking at this, it's sometimes a little bit easier to identify what the domain and range are going to be. So let's talk about the domain. The domain of every single quadratic function is all real numbers. So we already knew that the domain is all real numbers. It's the range that for each one of these quadratic equations will be slightly different. So the range in this case, it looks like it goes all the way from -infinity up until the y value of -1. However, of course, it does include that y value of -1, so that should be a closed bracket. So there's my domain and my range. And then from here, we can still find our intervals of increasing and decreasing as well. So let's go ahead and do that. I'm going to talk about my interval of increasing. It's increasing, it looks like, on the first half of the parabola. So that would be from -infinity. Now, increasing and decreasing are always x values. So -infinity to 3, that x value of 3. And then it's decreasing in the second half of this parabola, which looks like from 3 to infinity. Okay. All right, so that's what we have. That's the sketch of our graph. We've got the domain, we've got the range, we found the vertex, we found everything. I'll even rewrite the vertex here so we can have it all on the same page. Our vertex was 3, -1. Our axis of symmetry was x equals 3. Our max value was -1, and you can even see from the picture that is definitely the maximum value. And we've got our domain and our range. Ta-da!